Now, after we study the different type of atomic orbital, let's try to solve this problem. How are the orientation of the dxy and dx square y square orbital similar, and how are they different? If you want to solve this problem, first thing we should do is just to draw the two atomic orbital, okay? Then we can know what is the similar and what the different between them. So if I want to draw them, so I have dxy and dx square y square. So I will draw the plane here. So in dxy and dx square y square have the same plane, is lie between the same plane, is an x and y plane, okay? Have the same plane. So that the first thing that dx square and y square and dxy have, okay, the first thing that this two type of d orbital similar with is the type of plane. So they found in xy plane, okay? Now I will start to draw the atomic orbital. Now this for dxy, okay, and this for dx square y square, okay? Now I want to draw the dx square y square and for dxy. So for dxy, look at the location of electron cloud. It's between this x-axis and y-axis. It's between the x and y-axis. Now look here. For dx square y square, the location of this electron cloud on the x-axis and on the y-axis, okay? On the x-axis and the y-axis, here between the x and y-axis, okay? And not between them, in the x-axis and on the y-axis, here between them. Now what the similar and what the different between them now? So look at the shape of this 2d orbital. They have the same shape. They have the same shape of clover leaf, and they found, or they have the same plane. They lie in the same plane. Now what's the difference between them? The difference between them that in dxy, this orientation for this orbital is between x and y, and here on y-axis, or during the x-axis and y-axis. That's just the difference between them, okay? The exact orientation for this atomic orbital here, or for this electron cloud, is different. Just that was the difference between them. So the answer here, they two orbital have the same shape and they lie in the same plane. It's xy plane, but they differ in the exact orientation. Dx square y square is lie along the x and y axis, and dxy lie between this axis. So dxy lies in this, between this axis and here during this axis, okay, along this axis. Now we can go to the energy level. We talk about that, okay? And you know that the lowest energy level here in principal quantum number is n equal 1. We start with n equal 1. We don't have n equal 0, okay? So principal quantum number always equal the number of sublevel, and we talk about that in the last video. Now look here. This is a principal energy level, and this is the number of sublevel. If n equal 1, number of sublevel 1. N equal 2, number of sublevel 2. N equal 3, it's 3. N equal 4, it's 4. So the same thing is found here. Again, the principal quantum number always equal the number of sublevel, okay, in the principal energy level. The number of orbital in principal energy level is equal to n. What that mean? Again, I will back here from the last video. Now again, So the number of orbital or type of orbital found here is the same number of n. So how many orbital we have here? How many type of orbital we have here? 1. Here we have 2 type. Here we have 3 type. Here we have 4 type. We talked about that in the last video. So the number of orbital and principal energy level is equal to n. And I told you that in each of energy or in each orbital, okay, each orbital just can have 2 electron, okay, just need 2 electron. We can occupy it just with 2 electron, okay. So the maximum number for each orbital is 2 electron. So here how many electron? Just 2. And what about B? I told you in B we have a 3 type of B, Bx, By, Bz, and that means the maximum electron is 6 electron here. Because it's have a 5 type of d orbital, that means I will have 10, because each one of these orbital will have 2 electron, and F14 because we have a 7 orbital in F. I told you that in the last video. Now let's try to answer this question. What do orbits mean? What do we mean by orbits? Orbits is not come from Schrödinger or from quantum models. It's come from pure models. He said that I have nucleus here and I have electron. It try to move around this nucleus. Now I have electron, just move here and is move inside a circular path, okay, inside this path here, okay. So he move here, so he take a specific location inside this circular path. So what we mean by the orbits? So the orbits, for example, this is an electron, and they describe the behavior of electron as a behavior of large object, okay, we talk about that. So they describe the behavior of this very tiny electron as a behavior of object, and he say that this electron will move around the nucleus. So the orbit is that path that object can be take around inside the space around the another object. So what we mean again by orbits is that path an object can be taken around the another one, okay. So here is that path electron take around the nucleus inside the atom or in the space. Why are 2d and 3f orbitals not possible? Why? So if you want to answer this question, you should just draw the energy level. So let's start with n equal 1. So this is an n equal 1 now, and n equal 2, because we have n equal 2 and n equal 1 and n equal 3 and n equal 3. Now I have this 3 energy level. Now in n equal 1 we just have one sublevel, because the number of energy level should be the same of sublevel, so it's 1s. Just now in n equal 2 we should have just 2 sublevel. It's 2s. This 2 number here, this number is number of level, so it's an s and b. So 2b. Now in n equal 3 we should have just a 3 type of sublevel, is an 3s, a 3b, and 3d. So how many type of orbital we have? How many type of atomic orbital? We have a 3 atomic orbital here, a 2 type of atomic orbital, and 1 type, because we should have the same number of sublevel and the same number as energy level. The sublevel number should be the same as energy level. Now I have 1, that means I have 1 sublevel. I have 2, I have 2 sublevel. I have 3, So that means I have 3 sublevel. I have 3 different type of atomic orbital here, 2 atomic orbital, 1 atomic orbital type. I talk about the type of atomic orbital. Now, and let's write the number of electron now. So in n equal 1, I have 2 electron. In n equal 2, I have 2 electron and 6 electron. And here I have 2, 6 and 10. So we talk about the maximum number of electron. So in energy level number 1, I just have 2 electron. I cannot add any new electron. I cannot add any new electron here. Here in level number 2, I should have just 8 electron. And here I should have just 18 electrons. I cannot add any new electron here. Now if I want to add a new orbital, okay, I want to add 2d, for example, in energy level number 2. Why? Because he write 2 here. So if he want d, he want it in 2, not in 3, because we have 3. So if I want to write here 2d, that means if I added 2d now, that means I will add 10 electron. So that means I will not have 8 electron now in energy level number 2. I will have 18 electron if I added 2d. So that means I increase the number of electron in energy level number 2. So energy level number 2 just need 8 electron. So that's why we don't add it 2d. That's why we don't have 2d, because the maximum number of electron is 8. If you added d, that means you increase the number of electron from 8 to 18, and that is not correct. We cannot have 18 electron or more than 8 electron in level number 2. The same for d. Now let's go to d. Now this is a d. In d orbital, look, I have 18 electron. If I want to add the 3f, he want to add it in level number 3 because I have 3 here. Now, if I added f, how many electron in f? We can add it 14 electron here in f. So 14 and 18 will have 32 electrons. So we can add electrons. We can have electrons from 18 to 32 electrons inside level number 3. But that is not possible. Why? Because we just have this maximum number of electrons. We cannot add any electrons, okay? We cannot add any new electron because the maximum number of electron here just 18. Then this level is end. Just we don't have any new electron here. We cannot add anything because the maximum number is 18. So we cannot have a 3f. So that's why we don't have 2d and 3f, because this energy level, okay, have a specific amount of electron. So we should have in the first level 2 electron just, and here just 8 electron, and here 18. So we cannot add any new electron to this energy level, and that is the answer. So in the first shell there is only one s orbital, and the maximum number of electron is 2 electron. So 1b will not found here. Now for second shell, 2s and 2b orbital exist, and that means the maximum number of electron is 8. So in the result, the 3f, okay, and 2d, the same for 3f, okay, and 2d it will not exist, and for energy level number 3 we cannot have 3f. That is the answer. Now this is a last question here. What's the difference between orbit and orbitals? Look, orbit is come from pure metals and orbitals from quantum metals. Look, in orbit, I will draw the orbit. This is an orbit. We talk about what the meaning of orbit now. And this is electron. And this is an orbital. Do you remember the electron cloud? this is an orbital. It's an electron cloud. It represents the probability to form the electron here inside this electron cloud. This is an electron cloud. And this is an path or circular path that can object take around the another object, or a circular path that electron taken around the nucleus. Okay. Now what the meaning of, or what the difference between them? So in orbit, again, look here, it's a circular path, okay, circular path around the nucleus in which the electron can be found and come from pure metals. Now what about orbital? The orbital, in orbital here is a three-dimensional space around the nucleus. That means it represents this electron cloud, okay? It represents the electron cloud around the nucleus, okay, and it's come from quantum mechanics metals, okay. So that the difference between orbit and orbital. And that is the end of this video.